Last week, we brought you some of the highlights from the Consumer Electronics Show here in Las Vegas, but we couldn't fit it all into one programme. So we have more from those tech-laden aisles, including some of the latest innovation, hoping to monitor and mend our health like never before. Well, this device, which is the Withings Vimo, might be able to help us for some remote doctor appointment data. Now, instead of having all the kit that you might find in a surgery, well, it does the basics like temperature. There's a sensor that works just like this. You could also take an ECG by just holding your fingers here, and it'll also provide you with your blood oxygen levels. The most exciting feature, though, is that this works as a stethoscope. I know it doesn't look much like one. Now, it syncs to an app that will give you instructions as to exactly where you're meant to use it. You rub it across your skin and it'll take recordings. Those recordings can then be sent to a healthcare professional because the chances are we can't really interpret them ourselves. You can listen to them through a pair of headphones, but this is really just hoping to enhance the remote doctor experience with some of that vital data that you otherwise can't really provide. It's also another of a growing selection of healthcare products that help you be able to take regular readings instead of just those ones that you might do in a doctor's surgery. It should be available later in the year. And when it comes to getting a full picture of our health and well-being, medical gizmos and wearables can't do it all. You might also want to be aware of exactly what you've eaten, and it can be quite hard to input that data, especially when the weight of what you're having needs to be put in. So here is Callo AI, a system that allows you to photograph what you're eating, and it should be able to work out the content of it. It's not the most exciting of meals, just a bit of lettuce and chicken, so only 200 calories in there, but it also breaks down the ingredients. So you can see here the information for the lettuce, and here the information for the chicken. It is also trying to assess how much you've had of each, which may be a little bit easier if it's accurate than trying to quantify it yourself. Also, you can store all the data in here, so it means you can hang on to what you've had and even how much you've enjoyed it. Not that I imagined that meal would have scored so well. Elsewhere on the show floor, this device is trying to solve a problem that I think a lot of people would like a solution for. Niastem is trying to overcome baldness. It's suitable for men or women and aims initially to prevent further hair loss, but after 3 months is claiming that it can start to rejuvenate the hair again by stimulating more hair growth. If this works, well, it could be quite something. You pop it on just like this and wear it for 30 minutes a day and just get about your normal business. You don't mind having this on your head, that is. This uses bioelectrical stimulation. How does it work?
Well, we are creating a grid work on your head by pulsing with millisecond pulses through your entire scalp, thus energizing and activating your hair follicles. Because the technology comes from wound healing, and we cross-applied it to hair growth.
How did it do in the trials?
It performed actually very well. We had a 6-month trial, and it showed that it was 6 times better than the leading drugs.
You have great hair. Are you going to tell me you were bald before?
I had good hair from the beginning, but I worry a lot about it, and I use it also every week.
Right, okay. I wasn't serious, but that's good. Anyway, on to those who are hairier than most of us. It's not just about us humans. This is Minitail's latest device. You could think of it as a smartwatch for dogs. Not that it's worn on a paw, it's actually worn in the collar here. Now, the company has had previous devices that have tracked activity, but this time round, it's all about health, including monitoring for AFib, which is an irregular heart rate, which can happen quite often in smaller dogs. It's suitable for dogs of all size, and then you can take a look at all of the data on the phone. Then all of that information is stored within the app. It's a mixture of the health data plus what else this sensor is picking up. So it's also identifying whether the animal has been eating or drinking and how often, and if it's been barking, maybe when it's left home alone. There's one sensor in there which manages to identify a lot of different things through the AI system which is going on in the background where masses of data is being crunched. And they're just some of the ideas showing how all of our future health could be better logged, recorded and predicted as mass data and AI come together.
Now, car tech was everywhere at this year's CES. We had demos on the show floor as well as across the city. Paul Carter has been to see a race with a difference.
These are no ordinary race cars. And despite the smooth overtaking, these racing manoeuvres aren't all that they seem. I'm at the Las Vegas Motor Speedway, and this is the Indy Autonomous Challenge. And none of these cars have drivers. Well, not human ones at least.
Indy Autonomous Challenge is a research initiative where we bring universities from around the world and companies that are working in the autonomous vehicle space, and we try to advance the technology through the platform of motorsport by running fully autonomous race cars with AI drivers that are coded by top research university teams. The idea is to try to prove that autonomous technology can work at extremely high speeds. What you'll see is fully autonomous race cars racing each other two at a time, passing each other at increasingly higher speeds until one car either crashes or gives up, right? And we can say that because there's no driver in it, so if it crashes, it's just costs some money. You know, the speeds that we've achieved in the past at this track have topped 180 miles an hour.
This was a test day where the various teams from top universities around the world were tweaking both the cars and their AI drivers to try and gain maximum advantage. So what exactly are the challenges in trying to make an AI racing driver?
Well, there's multiple challenges, right? First is the perception. So getting all of the sensors, the LiDAR, the radar, the cameras to all work right. You have the communication technology. So how do you have really low latency communication? If the cars are moving that fast, you need to stay connected with them all around the track. And then there's the uncertainty of what the different AI drivers are going to do. So if a car is driving by itself, that's one challenge. If you put a second car or even a third car out there, now it has to predict what the other driver is going to do, and that can be really difficult from a computational standpoint.
Everything that the opponent does, our car has to react to in real time the same way a race car driver would. As the car changes lanes, as it makes decisions to try to overtake, we have to predict and adapt and move in order to make real-time decisions that could cost us the win or the loss. The challenges to making race cars race autonomously is exactly the same challenge as having a human do it. As you can tell, there's a very small percentage of people in the world who can actually race these cars. And imagine getting a team of software engineers together and to try to make that a reality in software that's making decisions in real time to compete against other software that's making decisions in real time. So it's not a trivial task.
Like regular autonomous vehicles, the race cars in the IAC rely heavily on LiDAR to identify their surroundings. One of LiDAR's big advantages is that it can operate in low light. And to show this capability off, the main event of the track week was pitting the AI cars against each other completely in the dark. But as fun as watching self-driving racing cars hurtling around in the dark is, this isn't just about entertainment. There is a serious side to all this. The main goal of this project is to advance understanding around vehicle autonomy, with the aim of ultimately making self-driving cars operate more safely at higher speeds.
Much of the industry has focused on low-speed automation, kind of the urban-suburban robotaxi. We saw that, and in 2021, we came out with a new challenge to say, what if we could prove that this technology could work at speeds, let's say, greater than 100 miles an hour? And we think this is really important because eventually, if we're going to have autonomous vehicles, we really want those vehicles to keep us safe at speeds that humans are not really comfortable driving. And once you get to 100 or 130 miles an hour, unless you're a professional race car driver, you really shouldn't be driving at that speed. But think of what it would mean for the world to have cars moving people, moving freight at those kinds of speeds.
The Indy Autonomous Challenge is now expanding outside of the US, with races at iconic motorsports venues such as Monza in Italy and Goodwood in the UK. Autonomous driving technology continues to develop at speed, both on the road and on the racetrack.
That was Paul. And that's it from us in Las Vegas. We've had a blast.
We certainly have. Thank you very much for watching. Hope you enjoyed it too. We'll see you soon.
Bye-bye.